Now we are going to discuss an important points from IS 456. First one is minimum nominal cover. The clear cover shall be provided to develop desired bond strength throughout the perimeter of steel to protect against corrosion and fire. The minimum cover required for slab is 20 mm, for beam 25 mm, for column 40 mm, for footing 60 mm. The spacing of reinforcement as per IS 456, the horizontal distance between two parallel main reinforcements shall not be less than the diameter of the bar if the bars are of equal diameter, the diameter of larger bar, or 5 mm plus nominal size of the aggregate, maximum spacing as per the design. For further reading, you can go through the page number 166 of AK Jain, the textbook. The limits of reinforcement as per beam, you can for beam you can design as per design procedure. You can find the exact quantity of the reinforcement, but the maximum quantity of reinforcement required is 4% of the BD. In compression member, 0.2%. Web reinforcement is 0.1% of web area. Vertical shear bars not exceeds 0.75 D or 300 mm, whichever is less. Minimum shear bars as per 26.5.1.6. For slab, the minimum reinforcement required is 0.12% if the reinforcement you are going to provide is Fe 415 and 0.15 for Fe 250. The stirrups shall be minimum size of 8 mm in case of lateral load resistance. The hooks shall be bent to 135 degree. In column, size of bar not less than 12 mm. The spacing of bar not greater than 300 mm. The arrangement of lateral ties should be as per clause 26.5.3.2 IS 456. The development length of bars. Actually, for a concrete grade M20 and steel strength Fe 415, for tension, the development length normally we provide is 47 times of the dia for tension bar, tension member, and for compression 37.6 times of dia. So this is the an approximate development length for tension and compression members if the according to the reinforcement is varying for 8 mm to 32 mm. If dia is 8 mm, for tension member you need to provide 376 mm development length, and for compression 301 likewise. Approximately you can say that for tension member instead of 47 you can provide 50 times of dia as a practical, as a thumb rule. In compression member you can take it as 40 dia. Lap splicing clause 26.2.5.1 as per IS 456. Let's see what are the conditions for that. The lap splicing as per clause 26.2.5.1 IS 456 says the lap splicers should not be used for bar larger than 36 mm. Larger than 36 mm bar may be welded. The lap length including anchorage value of hook in flexural tension is development length, actually the LD, or 30 times of dia, whichever is greater. Lap length including anchorage value of hooks in direct tension is 2 times of development length, or 30 times of dia, whichever is greater. The straight lap length should not be less than 200 mm or 15 times of diameter, whichever is greater. Lap splicing. Lap splices are considered as a staggered if the center to center distance of the splices is not less than 1.3 times of the lap length. The lap length in compression is equal to the development length in the compression but not less than 24 dia. Lap length is calculated on the basis of the diameter of the smaller bar when bars of different diameters are to be spliced. Do's and do nots in detailing. Prepare drawing properly and accurately. Prepare bar bending schedule if necessary. Indicate proper cover to reinforcement. Decide location of the opening and holes and supply adequate details for the reinforcement around opening. Commonly available size of bars and spirals shall be used for the reinforcement. For single structural member, the number of different size of the reinforcement bar should be minimum. The grade of reinforcement bar should be clearly mentioned in the structural drawing. When reinforcement is left exposed for future construction, it should be adequately protect from the corrosion and weathering, like dummy column. Congestion of the reinforcement should be avoided at the points where members intersect and make certain that all the reinforcements shown can be properly placed. Show enlarged details at the corners, beam and column joint and at the similar special situations. Denotes for detailing. Flexure reinforcement shall not be terminated in a tension zone. Lap splices should not be used for bars larger than 36 mm. Different type of reinforcing bars such as deformed bars and plain bars and various grades should not be used side by side, as this practice would lead to confusion at site. Do's for columns. A reinforced column should have minimum 4 bars for rectangular or square column and minimum 6 bars for circular column. Keep outer dimensions of the column constant as far as possible for reuse of forms. Preferably avoid use of 2 grades of vertical bars in the same element. Do's for beams and slabs. Where splices are provided in reinforcing bars, they should be staggered and away from the sections of maximum stress. Where the depth of beam exceeds 750 mm in case of beams without torsion and 450 mm with the torsion side face reinforcement shall be provided. All spacing shall be center to center spacing of bars. Deflection in beams and slabs may be reduced by providing compression reinforcement. At the beam column intersection, ensure that the main beam bars avoid the main column bars. At beam column intersection, main reinforcement may be arranged that layers in mutually perpendicular beams are at different levels. To accommodate bottom bars, it is good practice to make secondary beams shallower than the main beams, at least 50 mm. Then we are going to curtailment of the reinforcement. Instead of we are providing some bend up bars, the curtailment reinforcement is doing. This is the way we are doing now. The extra bar or the reinforcement at tension zone at support. So the flexural reinforcement shall not be terminated in a tension zone unless any of 3 conditions is satisfied. Shear capacity at end of bar is 1.5 times of this applied shear, that is 1.5 times tau v should be less than or equal to tau c plus tau b. I think all the technical terms you have already studied. The stirrup area in excess that required for shear and torsion is provided over a distance equal to 0.75 d from each cutoff point, that is a greater than or equal to 0.4 bx divided by sigma v, where x is equal to d by 8 sigma b, where sigma b is the ratio of the area of long bar cutoff to area of tension bar at that section. For 36 mm smaller bar, the following may be satisfied at the cutoff point, that is 1.33 tau v should be less than or equal to tau c plus tau b. The area of continuing bars should be at least twice that required to resist the applied bending moment. Positive bending moment reinforcement has to be provided as per IS clause 26.2.3.3, and negative moment reinforcement as per clause 26.2.3.4. Curtailment of the bended bar as per clause 26.2.3.5. Okay, you need to go through these lines in clause IS 456. Bar bending schedule. The bar bending schedule should be include identification of structural member, position of each bar in member, bar marks and diameter of each bar, number of bars, shape and bending dimensions of each bar, length of each bar, and remarks if any. Thank you.